So, in this session, your question is the sequential reaction in which the methyl cyclohexane undergoes bromination Br2H nu. Bromination is very selective. As you know, the selectivity of halogens, their bromine is very much selective. Its radical substitution and its selectivity is tertiary, secondary and primary. So, through this radical substitution, the first product, what you say A, is 1 bromo, 1 methyl cyclohexane. This is tertiary place, so preferably there that this bromination takes place here and you get 1 bromo, 1 methyl cyclohexane. Fine. Next, this A is treated further with the alcoholic KOH in C2H5OH. You know, the KOH in C2H5OH is very good for E2 elimination bimolecular. This is anti-elimination, although in this case it is not much concern, but you should know that E2 is anti-elimination, elimination bimolecular. And here in this context, this one is Sedgwick's product. It means here that kind of alkene forms that beta hydrogen is lost, abstracted out, which will produce here the possible most stable alkene, and certainly this one either from this place or from that place. So the product is now double bond forms here 1 methyl cyclohexane. Fine. You know, this one is further, as per this question, you see that this is treated with O3 in the following treatment of ZnH2O. This reaction is called ozonolysis with the reductive following reduction. ZnH2 is reducing one, and so in this case their cleavage takes place. This kind of ozonolysis gives here C double bond O CH3, cleavage takes place here, and this one is C double bond O and there the H. You see this question, your next one is there, this is diketo compound and that is treated with HO minus. What is this reaction? This reaction is Aldol condensation. Aldol condensation, and here you will find that this is the intramolecular. This one is intramolecular aldol condensation. What does it mean? It means it has aldehydic, it has ketonic part, and you see this is the first, this is second, this one third, this one fourth, this one fifth, sixth, and this one is seventh. So one side enolate will form and that enolate will attack on the other keto compound within the molecule, and then there the very first aldol will form, and that is followed by the dehydration, as you know, that will give there the condensation product. Here this is interesting point. Anyway, you know that this part, ketonic part, will give enolate preferably, and nucleophilic addition is more preferred here. So although there are the various possible products, if this will attack here, this can also attack here, 1, 2, 3, 4, 5, this kind of one of the product. There is another product that this 7th carbon atom will form the enolate, this will attack here, in that case 1, 2, 3, 4, 5, 6, 7 bonding will form. In other one, that this 5th carbon atom will form the enolate with this C double bond O, and this will attack on this, so this will 1, 2, 3, 4, 5 bonding will form. Out of these 3 possibilities, the most appropriate one is the 5 bonding attack of this 5th carbon on this first C double bond O, because enolate is more stable here, and this facilitates, this has the greater ease of nucleophilic addition reaction, so the enolate will attack here. This will come up. I write here stepwise that how this is converted to now the OH, and this one is now C double bond O into the CH3. This kind of aldol will form, but you know HO minus, there is one hydrogen, this hydrogen is lost, and finally their dehydration takes place. This dehydration takes place in the basic medium. This basic medium, I mean to say, then you will say this dehydration as the E1CV, elimination unimolecular conjugate base process. And through this E1CV, here this dehydration takes place, and so the final product is now double bond here, C double bond O, and there the CH3. This is always, you can say, alpha beta unsaturated product. This one is condensation product, that forms here in this case. This is the final product. So your question was, when this methyl cyclohexane reacts with Br2HNO, what is the product A? That is treated with alcoholic QH, then what it forms. So your B is like this. This is the methyl cyclohexane, and that is treated with O3 ozone, and the following treatment of ZnH towards the product right now, that is your C, and that is treated with HO minus. So what is the final product? D. So this is D. I hope everything is clear. Thank you.